You know, if I was really smart, I would hit the unmute button before I actually start the broadcast. Good morning, everybody. So, hi, I'm Brent Ozar, and today I'm going to be analyzing your weight stats. It is a bright early morning over here in San Diego. The sun's just starting to come up. And I will be looking at the contents of your SP Blitz first with show or send startup equals 1. If there are any problems with the audio, video, whatever, just let me know and let's go ahead and get started. So I will switch over to my desktop. For those of you who haven't seen me do this before, I'm going to show you what I need from you if you're going to go send in your server's data. What you want to do is you want to run SP Blitz first, since startup equals 1. And the thing, this is a tool that we give away for free on the website over at brentozar.com. And this will then go give you your Technicolor Dreamer. Good morning. This will go give me the weight stats that you have. I want you to send me a screenshot or paste a link over in Imager showing the first 10 rows of SP Blitz first since startup equals 1. And I need the columns that are highlighted. I need to go all the way over from our sample over to average milliseconds per weight so that I can get a full picture of your weight stats. Now, the stream is technically scheduled for an hour this morning, but I'll go up to like 2 hours if y'all have a bunch of weight stats that you paste in here. The only thing I ask is only one server per person. Now, if you want me to analyze multiple servers, that's really best for things like a consulting. I try to give as much help to as many people as I can out for free out on the web. And for those of you who are pasting in your website or your weight stats and you're thinking, oh, I'm just going to wait until he does mine and then I'll leave. You know what I would do if I were you is I would stick around and watch the advice that I give to other people because you'll learn a whole lot about interpreting weight stats. If you've got these weight stats, go over to Imager. I should put the link inside there. After you take your screenshot, go over to Imager.com. Paste your screenshot into there. Just keep in mind you don't want to have anything, private or things that you'd worry about being shown publicly because it literally is shown to the public. And then paste your weight stats in here and I'll work through them first come, first serve, just going through them in order. All right. So now, while I do this, I'm going to switch cameras just because M. Bold says, morning, Brent. Yesterday, when you checked my company's SQL Server's weight stats, I was unable to thank you. Thanks for all the effort you put into this. You're welcome. I have a really good time doing this. This is now one of the favorite parts of my job is just randomly analyzing people's performance numbers and telling them as quickly as possible, like inside the span of 5 minutes, here's what I would focus on next if I were in your shoes. All right, let's go ahead and get started. Let's look at the first weight stat that was sent in here. I'm switching over screens on mine so that you can't see my screen while I do it, just in case somebody trolls me and puts something not safe for work up in their SQL Server's weight stats, like they're not really weight stats. Perfect, we got the first one up. So the first one up is, let's see, I believe it's Keys Janvey. So Keys Janvey, we'll say Keys Janvey. Let's go take a look at Keys Janvey's weight stats. Oh, he's even got fancy with he's got put in things with his the SQL Server. So it's SQL Server 2014, 4 cores, 12 gigs of RAM. I'm so used to seeing memory expressed in terms of gigabytes that I looked at those numbers and I'm like, 12,000, is that 12 terabytes worth of RAM? Woo, we're going to have a party. But it did seem kind of odd that it was 4 cores and 12 terabytes of RAM. On a NAS, oh, okay. So let's see here, the top weight type. So in 88 hours of uptime, the first column tells me how long the SQL Server's been up. And in 88 hours of uptime, it's kind of tough to draw conclusions. Thankfully, 88 hours means that it's been up, because today's Thursday, it's been up during weekdays. So assuming your workloads are pretty stable throughout the week, then this might be good enough. The number one weight type only has about 20 hours in it, which means that, so 80 hours of uptime, 80, 90 hours of uptime, only 20 hours of top weights. That means the SQL Server is just not working very hard. It doesn't mean that every query is fast. It just means that people probably aren't gathered around the server with pitchforks. As I go through and analyze other people's SQL servers, you'll see SQL servers where people will be gathered around with pitchforks because performance sucks. Now, when this thing does wait, so for these 18 hours, what was it waiting on? It was waiting to write to the transaction log. Every time that you do an insert, update, or delete to SQL Server's 8K data pages, we always think about having to change the data pages, but that's asynchronous. That's actually done later. SQL Server will cache these 8K pages, the changes that it's making to them, cache those in RAM, and then just gradually push those off to disk later. But in order for the transaction to be considered committed, that insert, update, and delete to be committed, we've got to write to the transaction log as quickly as possible. We have to write what that transaction's trying to do before it's considered committed. So at the server, it's interesting because it's not, normally we think of slow selects, but on this server, the top problem would be inserts, updates, and deletes. Is it a big problem? Well, not really in terms of the overall wait time. It's relatively low compared to the server's uptime. And when we do wait, this is one of those waits where I look at the average milliseconds per wait column. We're talking about only 2.4 milliseconds worth of wait time. That's pretty quick. For the longest time, Microsoft had a SQL CAD article out there where they said that transaction log writes slower than 3 milliseconds were poor. In this day and age, like you mentioned on here that you're working on a good old NAS with 15K disks, that's really heroic for 15,000 RPM disks. That's actually fantastic, 2.4 milliseconds of storage delay time. Plus, what I usually find is that when you're talking about inserts, updates, and deletes, people rarely notice a 2 millisecond overhead. Now, there are situations where they do. A .com, 24/7 .com, people doing stock trades, Stack Overflow. We're there where every millisecond counts and performance is a feature. Then it starts to matter. But I'll be honest, if performance is a feature to you, you wouldn't be using spinning rusty magnetic frisbees for your storage. If I was a manager, if I owned the company, I would say, well, convince me that I need faster storage. I don't know that I could do that because the users aren't probably going to notice the difference between 3 milliseconds and 1 millisecond. That's not the kind of thing people high-five each other over in the hallway. So on yours, what I would say is if people are complaining about queries, I would actually look at the queries rather than the server. You don't have a server level problem that's catastrophic, just glancing down at the rest of the weights. This would be more of an issue of query tuning, asking people, okay, what query do you think is slow? And then what can I do in order to make it faster? Richie says, I'm making tea. Anybody want some? I just brewed a fresh little espresso before I got started too as well. So take a moment to take a sip of my tasty beverage. So there's yours. I actually don't have recommended next steps for yours. I'm happy with that. You're doing pretty well. I'm going to go and move on to the next server, but feel free to ask follow-up questions if you want to know more about the weights that I saw. All right, let's switch over and see what we have next. So let's see here. Next, we have an SS3668. Let's take a look at those weight types, and let's go see what we've got. Paste that in, and let's switch cameras back in. So on here, this is fairly small. This is pretty doggone small. It's kind of hard to even read that. I think you took a real low resolution screenshot there. Oh, I forgot to say who this is. So the person who this is was one SS3668. So SS3668, your server, and it's looking through Vaseline goggles here, your server's only been up for about 38 hours, and in about 38 hours, you've got some full text waits. I'm not generally concerned about that. That's basically updating full text search in the background. What I'm going to do is go past that and look at the next biggest wait, and your server spent not even like 20 minutes waiting on backups. Your server's bored out of its gourd. What I will say, though, is because we only have 37 hours worth of wait stats, it could have been bad 3-4 days ago. Generally speaking, don't restart your SQL server unless you absolutely have to. There's a lot of good, juicy diagnostic data that SQL Server only keeps in RAM, and when you reboot SQL Server, you give it amnesia. So, all right, let's take a look at the next one. Let's see who's next. Shelty Lover. Shelty Lover is next. Let's see what Shelty Lover has. So paste that in. switch over to Shelty Lover screenshot. So Shelty Lover screenshot says, in roughly, what is it with all of y'all and your reboots? Oh my goodness, everyone today is rebooted. And like, it's really funny. Yesterday, in yesterday's session, everyone had kept their hours out. S360, 60, 67, 68, you're welcome. Everybody yesterday had been up for like 6,000 hours, and I'm like, y'all need to patch your SQL servers. If you've been up for that long, there's a problem. Now y'all are like rebooting your SQL servers like they're some kind of laptop. 40 hours worth of uptime just isn't really that much uptime, so it's tough to tell. It's not even 2 really full weekdays there. However, I'm going to make a judgment call based off of what I see. I would just be really hesitant to take action on this because it's such limited information. So the top one, the top weight, 71 hours and 40 hours of uptime. That means roughly for every 1 hour, you've had about 2 hours of wait time on this particular weight, CX packet. What is it? Well, it's hard to tell in the older version of SQL Server that you're on. And I say older, you're on either 2014 or prior, or else you haven't patched 2016 to current levels yet. Because this weight type was really cryptic for a long period of time. I'm going to talk like over to the camera for a minute. So CX packet weights were really hard to interpret for a really long period of time. Follow the bouncing server. Oh, Shelty Lover says 2016 non-patched. Oh, you just rebooted 40 hours ago. Why didn't you patch while you were rebooting that server? This is one of those weight types where you really want to patch, because Microsoft, for the longest time, couldn't give people advice based on CX packet. Server admin. Somebody else was over there playing Butterfingers, or as we like to call them, chaos monkeys. They were running around and unplugging servers. So you really want to patch this one if you can, because Microsoft injected all kinds of new diagnostic stuff in 2016 across the span of several service packs and cumulative updates. One of the things that they added was the ability to split CX packet into 2 different weight types. You don't even, I almost made it sound like you have to do something. You don't. All you have to do is patch. And then SQL Server will automatically split CX packet into 2 different weight types. Supposedly, one of those, CX consumer, is harmless. In reality, well, it still can be kind of harmful, depending on what the query workload looks like. So I'm going to mention to you only the importance of patching, and everybody else on the call as well. I know I also run, Shelty Lover says Service Pack 2. Well, the easiest way to go see is go open up a browser. Let's go open up a browser and let's go to SQLServerUpdates.com. This is a website that I run that lists the most recent service packs and cumulative updates. And generally speaking, I recommend going straight to the latest cumulative update that's on this page. So Shelty Lover, in your case, you're on 2016. You would go download Service Pack 2 and then Cumulative Update 12. And if you click on those, each of those are hyperlinks. You only have to apply the most recent service pack and the most recent cumulative update. You don't have to apply all of the service packs and all the cumulative updates. The cumulative updates are what you would call cumulative. They have all the patches included. So SP2 and cumulative update 12. Now, having said that, looking back at your weight stats, what that's going to do when you get fully patched is it's going to split this parallelism number into 2 different weight types. But you know, this isn't urgent. Your server's not on fire. This isn't really bad weight stats situation. What I'll usually do is then go drill a little bit deeper to see why our query is going parallel. And just at a glance on your weight types, I have a feeling they might be going parallel because maybe somebody hasn't set cost threshold for parallelism and max stop. So for Shelty Lover, thing that I would say, Lover, is set CTFP and max stop to sane defaults per, it says set per your recommendations. You're just trying to make me feel better, aren't you? I will take that because people don't do that very often. And I'm going to type this out just because other people are going to ask what sane defaults are. So I talk about sane defaults there in that page. Then after you do that and you patch, so I'm going to say in here patch Then also, and I'll say just to be good, to 2016 SP2 CU12. The thing you're going to do after that is you're going to run SP Blitz Cache sort order equals duration. What this is going to do is it's going to show you your longest running queries overall in total. It's super rare that I suggest that to people, which sounds kind of funny, but usually I slice and dice by other methods. Shelty Lover, the reason why I'm telling you that, though, is not only do you have CX Packet, you also have this one in here called Async Network I/O, which means that SQL Server finished building the query results, and now it's trying to send them across the wire to the application, and the application isn't acknowledging it fast enough. Meaning that maybe the application's doing row by row processing, maybe it's over a really small or really long WAN or wide area network, maybe it's a really underpowered app server, but this will start to help you get to the queries that are taking the longest time, and that may be because the apps aren't digesting the results fast enough. If you want to learn more about that, over in my Mastering Server Tuning class, I have a module called Async Network I/O. So if you search for Async Network I/O on our site, you'll get a module talking for about 45 minutes about the whole story behind that. I'll be honest, though, in yours, it's in pretty good shape. I wouldn't freak out. The thing that I would just do is patch. Just make sure that you patch, and you've set cost threshold and maxed out to saying default, so that's good. All right. Next up, let's see what we have next. Shelty says, thank you. You're absolutely welcome. All right, let's see who's next. So that was Shelty Lover. Next up is the Mike Scalise. So let's get Mike's weight stats and paste those in and then switch over again. So Mike, what the hell? You got a patch, man. Mike, come on now. Mike, your server's been up for 13,000 hours, and you're on a relatively recent version of SQL Server. So you're on either 2016 patched, or else you're on 2017, 2019. Hell, I don't think you could be on 2019 with this level of uptime. You've been up for a really long time. It is time to patch this server. Holy smokes. So in here, setting that aside for a second, the problem with analyzing weight stats when a server's been up for 13,000 hours is that maybe the problems it had in weight stats were 6 months ago, or maybe they all happened last night. Because these numbers are cumulative over time, it can be kind of tough to tell. But what I'm going to do is I'm going to assume that the server has looked exactly the same way. He says 530 days of uptime. That is not something to be proud about. That is something to be ashamed of in the SQL Server community. And this is hard. I know it's weird for us because a lot of us take pride in uptime. And I'm going to take 2016 as an example. So 530 days. It's about, a year and a half ago? So a year and a half ago, what were the patch levels looking like for 2016? I suck at math, so April, a year and a half ago, would have been like October of 2018. So way down here, this is probably the patch levels that we're looking at in here. There's been an entire set of 12 cumulative updates since then with all kinds of gotchas. So Botsko says, how often is good to patch, or do we need to restart from time to time? You don't ever need to restart SQL Server. I say you don't ever. There are edge cases where you do, there are memory leak bugs where you do need to restart. But most of the time, you don't need to restart. You do, however, need to patch. So on current versions, and I'm going to pop back out and show you what I mean by current versions. On current versions, say 2019 to 2016, you're usually talking about a patch coming out around every 60 days. Sometimes it's 20 some days, sometimes it's 90 days, depending on which one of these it is. Generally, the newer version of SQL Server you're on, the faster that the patches drop. Then, as the thing gets older, like 2014, 2012, patches don't come out that frequently. To see how often they come out for your version, what you can do is click on, over on the right-hand side here, Other SQL Server Updates, and then you can see the dates on which the releases have dropped. So for 2016, there was one on February 25th. There was one on February 11th. There was one on December 9th, or October 8th. So you're looking at roughly every 30 to 60 days, ballpark. Okay, so back over on yours though, I'm going to assume that yours looked relatively stable across the span of these 13,000 hours and that the weights always looked like this. I'm doing a scratch. In there, for every 12, for in 13,000 hours, you've spent less than 1,000 hours waiting on the top weight. Even when I add all these up together, most of the time your server's not waiting on things. Plus, of course, you have multiple CPU cores. Most of them are sitting around board. You're maybe keeping one core kind of a little bit busy. When the server is waiting, the top two weights both suggest that it's storage. Number one is writing to the transaction log. Number two, Richie. Number one is waiting on the transaction log. Number two is waiting to read data pages. So both of these are really storage related. If I scroll across in here and I look at how long we're waiting when these happen, the top one kind of blows. The top one, remember, was writing to the transaction log. When we're writing to the transaction log, it's taken around 20 milliseconds. I'm going to guess that you've outsourced your storage to a small old man who lives in a hut down by the sea, and he's writing down your transaction log on papyrus in the finest calligraphy. It doesn't work too quickly, but boy, are those transaction logs beautifully done. Says, it's someone else's there. So because of that, I'll leave that out. So because of that, the storage isn't very good. 20 milliseconds for transaction log writes. I mentioned earlier, Microsoft likes to say that 3 milliseconds or more is poor. I think it's kind of ambitious. The number I usually throw around is at 20 milliseconds for write. It's poor. Your reads aren't that bad. Your reads are around 10 milliseconds, but the writes are no bueno. So what can you do to fix that? Well, you could move to faster storage. The first thing I'd actually say is if the server's been up for like 530 days, I'd probably start asking questions about the kinds of hardware it's on, whether or not we're thinking about improving that anytime soon. If you wanted to improve that, one thing you could look at, there are two things that you could look at. So this is for, let me scroll back and see who exactly this was. This was Mike. Okay, so for Mike in for yours, what I would do is I would start by saying SP Blitz Index get all databases equals 1, mode equals 2, copy, paste into Excel, sort by user updates descending. What you're looking for when you run SP Blitz Index get all databases equals 1, mode equals 2, this gives you like a spreadsheet friendly output of all the tables that you have and the indexes on those tables. What I want to do is I want to get rid of indexes that are only slowing me down. I want my storage to be doing as little writes as possible, especially for indexes that I'm simply just not reading. So to do that, you're going to scroll across over to the user updates column, and you're going to sort by that descending. You're going to have to copy paste into Excel to do that because, of course, clicking on columns to sort them is apparently too hard for a database product. So what you're going to do is you're going to copy paste that into Excel, sort by updates descending, and what you're looking for is indexes that have no reads, which means they're only being maintained and they're not making your queries go faster. To learn more about that, if you want to learn more about that technique, that's my Fundamentals of Index Tuning and Mastering Index Tuning classes. Now, I don't know that there's going to be a whole lot of high bang for the buck there, because of course, who knows if you even manage indexes inside this database. The other thing that you can play around with is SP Blitz Cache, sort order equals writes. And what you're looking for are queries that are doing all kinds of writes, maybe not for good reasons. I'll give you a great example. So someone says check storage for TempDB. Not at all. That's totally unrelated. I like that you ask, but no, totally unrelated. So in here, what you're looking for then is queries that are doing all kinds of writes to tables temporarily. I didn't say to temp tables. I said they're using things like scratch tables in a user database, and user database changes are fully logged. It doesn't matter whether you care about the table or not. So it's one of those cases where I'd say, hey, if we're doing a lot of scribbling, like of staging tables for a data warehouse, you might consider TempDB. You might consider doing tables over there instead. Would I recommend storage changes? Probably not, just because it may be too expensive, and the server, to be honest, isn't really overwhelmed. But if you had to pick something to focus on, that's probably the place that I would start. I find it kind of funny, just to mention as a side note, header sync commit, this means that you have an always-on availability group. Usually, when people have an always-on availability group, usually that weight is at the top of the list, because it takes a while to send your inserts, updates, and deletes over to the other replica and commit them. Here, the primary has got that, old man by the sea calligraphy storage for transaction logs. So it turns out that the header sync commit, your synchronous always-on availability group, isn't even the biggest problem. So that's kind of amusing. All right, so that was Mike. Let's see. Next up, let's go take a look at the next person. So the next person is Robin. Let's get Robin's weight stats out and paste that over there and switch back over. So Robin's is here. Oh, Robin, yours is very similar. Oh, it's funny how that works. Robin, I would like to high-five you first, though, for keeping the right amount of uptime. So you have about 608 hours worth of uptime, which is enough that I feel confident in saying server's been up for a while, weight stats are pretty predictable, I should be able to make some good diagnostics here. In here, your number one weight is just like Mike's was. You spent about 200 hours waiting to write to the transaction log, which just means inserts, updates, and deletes, and nothing else. You can theoretically have selects that do writes, like select into a table. That's fairly unusual. Your storage, though, is what Mike wishes he had. Your storage only takes 1 millisecond per transaction log, right? Mike might be the time that you go talk to Robin, like over in chat, and say, hey, tell me more about your storage, and maybe I can borrow some. Maybe I can put my databases over there for a while. To come back over to that, so to make yours faster than that is going to be extraordinarily expensive. Well, it's going to be challenging, because you would end up moving your transaction log to things like local solid state storage, which has other problems around things like reliability. So you're not going to make that much faster in terms of the storage throughput. My advice for you would actually be exactly the same as Mike. So Robin, on yours, I would say, go look at indexes that aren't being used, that are getting a whole lot of writes and aren't necessarily being used. And then also look at queries that are doing the most writes. But Robin, I'm going to tell you one other thing that may help inside here as well. So in here, another thing I want you to sort by rows descending and sort by, I want to say it's called space reserved. So there are a couple other columns inside SP Blitz Index, and I'll tell you what I really love doing. It's those two right there, rows and reserved megabytes. So sort by reserved MB descending. What you're going to do, Robin, is you're going to sort by your largest tables and largest indexes, and you're going to ask questions to your users like, and developers, did we really mean to keep all this data in here? Because true story, this happens to me all the time. True story, all the time when I'm doing consulting engagements with clients, I will run that exact script and I'll say, okay, everybody, let's just look at the projector and walk me through, why do we have 2 terabytes worth of data in a logging table that we never use? Like this table has 2 terabytes worth of stuff, 5 billion rows, it gets tons of updates, and it's never had a read ever. Why are we hoarding that data? So that's kind of amusing to me because it helps people understand. MFA Solomon says Pretzel's really bored. That's my bot that just tells people automatically which music that I'm playing. Hopefully y'all can hear the music too, just as a real like faint side kind of thing. The thing that catches people all the time is they're like, oh, we had that logging feature and we forgot to turn that off. Or, oh, we didn't realize we were repopulating that table from scratch every night. It has 10 years worth of history. Oh, Drew cannot. Well, Drew, I don't think your hearing's bad, so I'm going to turn the music up just a little. Caruto says the music is Gucci. We'll turn that up and we'll see if it's... Nick points out GDPR was a good thing for anti-hoarding. Yeah, as a lot of companies went through GDPR compliance projects, they started running those lists of what data are we keeping the most of and how quickly can we please set that data on fire. Eamon says we may need it in the upcoming 10 years. I'm cool with that, but what I'll often do is I'll say, great, we're going to set up a separate database server for that. It's going to be on SQL Server Standard Edition. It's going to be on a couple of crappy Western Digital hardware or Western Digital drives that I bought from Best Buy. You can take all the time you want in order to insert the data over there. I'm not touching that, and I don't want it to interfere with the inserts, updates, and deletes on my production boxes. See if we can get the camera to set the white balance. Maybe not. All right. So now, let's come back over to, that was, let's see, the one after Mike Scalise. So let's see who we've got. That was Robin. All right, next up is Winter Mule. Oh, that's interesting. Winter Mule. So let's see. How often do I do this? That's a good question. If you go to my site, if you go to brentozar.com, /training/live. If you go over to brentozar.com /training/live, this is my streaming page where you can go. Now it's going to be like Inception because it's going to be me watching me, watching me, watching me. And it has, if you scroll down on there, it talks about my upcoming classes, both the paid ones and the free ones. So it depends. I work it into my schedule. I don't do a fixed schedule every time. So next up is Winter Mute 2.0. Winter Mute 2.0. That's interesting. So what? Y'all trolling me? That's almost the same server. So this one, everything that I just said to Robin and to Mike Scalise, same exact thing for you. Your storage at an average of 5 milliseconds. Your storage at an average of 5 milliseconds per write log wait is okay. It's not fantastic. It's not as good as Robin's was. It's not as bad as Mike Scalise's was. But the recommendations hold exactly true there as well. All right, let's close a few of those. Close. And let's see, show me the plan. So show me the plan is next. Let's see what show me the plan says. Show me don't play that game. Show me the plan says I've got about 513 hours worth of updates or worth of uptime. The top one is ignorable in this case. I have to leave it in there because sometimes it's ignorable, sometimes it's not. In your case, it's completely ignorable. The second one, though, ring-a-ding-ding. This is the exact same thing. What is it? It's today like Write Log Wednesday? It's Thursday, but, of course, it would make more sense if it was Write Log Wednesday. So on yours, about half of uptime, SQL Server has spent waiting to write to the transaction log. I'm going to say just the same things that I said there with the other folks on how to fix that, but you also have a couple of other interesting things inside here. You're on a fairly recent build of either SQL Server 2016 or newer. It's been patched. At least the 2016 would have been patched, or you're on a newer one. So you have these two parallelism weights that if I add them together, they run about 600 hours to 2016. So good. So you're patching. Oh, thank you. I appreciate it. So you're talking about 600 hours worth of parallelism weights. Now, parallelism in and of itself isn't necessarily a bad thing. However, I just want to make sure that it isn't Parallelism Gone Wild Spring Break Edition. So what you're going to do for Show Me the Plan is you want to make sure or set cost threshold for parallelism and max DOP to sane defaults. And Nick, you're in here, so you need to listen very carefully, Nick. Oh, I hope you're feeling better, Nick, too. I totally hope you're feeling better. BrentOzar.com, go CX Packet. So if you go to that site there, I explain what sane defaults would be for those settings. But then also on yours, after you set that, so just to make sure that you're not doing unnecessary parallelism and that SQL Server's not having problems balancing work across threads, the next thing that you're going to do, show me the plan, is down here, this line right here, you're going to stop running profiler traces in production. See how it says trace write, and it has 188 hours out of 512 hours your server's been waiting on trace write. So a brief moment of discussion about profiler tracing. A long time ago, when I was your age, before there were good monitoring tools, Show Me the Plan says it wasn't me. I get it, but someone else did, so we want to find out who that was. I swear, it was the last person. That's always the good answer, right? That's the thing that that was the other person. They're like, this is in the last 512 hours. And I'm like, they hacked us. Yeah, that must have been what it is. If you run SP Blitz, just plain SP Blitz, if you run just plain SP Blitz, it'll give you a list of everyone who's a sysadmin down in the security settings. The older me, I like that. Me when I was younger and I needed the money. And it'll give you the list of sysadmins anybody who's a sysadmin can go run profiler traces. SQL Server will slow down in order to accommodate a profiler trace to make sure kindly that your profiler trace can keep up. There are effective techniques that you can do like server-side tracing to reduce the mitigation on it, to reduce the overhead on it. The thing is, though, I would rather get you started on a more modern way to find the queries that are causing the problems, things like extended events. Now, it just so happens that Pluralsight is completely free for the month of April, so when this call is over, get the people, not you, of course, it was the other person, get the person involved who was running the profiler trace and do a lunch and learn, go through the Pluralsight courses on extended events. Jonathan Cahias has a totally free course on extended events. It's free all this month during Pluralsight, so go and take advantage of that. Aroxy says, as far as I understand it, parallelism is bad for lots of small queries. So one thing that I would say, and this is just a general life lesson, because we're all friends here and no one watches these streams. They don't know what your real name is. When you're attending a class, whether it's a class or whether it's a casual thing even like this, there are three kinds of chat messages or comments. The first, question to the instructor, the first kind of question is when Richie says we sell training. We do not sell training on extended events, and I never will. Not that I don't like extended events. I don't like doing training on extended events. Kind of a pain in the rear. So there's three kinds of questions. First kind of question is when you want to know something, when you're genuinely asking a question to learn the answer. Number two is when you're pretending to ask a question because you want to pretend like you want to seem like you know the answer. Like, oh, I know that such and such causes that. Don't do that. Because you end up looking like a moron if you're wrong. And if you were right, you'd be on the other side of the screen instead of the side of the screen where the microphone is muted. So if you decide that you want to do number two, if you decide that you want to show off your knowledge, you don't want to look like an idiot. So what you do is, I heard that rotating your muffler bearings improves fragmentation. Just say, I heard that. And then that way, if you're right, the presenter will be absolutely, Alex, you're completely right. Whereas if you're wrong, the presenter will be like, oh my God, Alex, where did you hear that? That's terrible. Don't repeat that. If it was my blog, go tell me so I can go track it down and find it. That way you don't look like a moron. Nick says, I heard sequel. I hear it in my dreams, mostly nightmares. Then the third kind of question just indicates that you weren't paying attention for the last 20 minutes. So off we go. So on yours, the thing that I would just say is stop doing that profiler tracing, go attend an extended events class and go from there. Next up, we have, so that was, let's go down. We got all kinds of interesting names inside here today. Let's go make sure that I got the right one. That's the most recent. Man, we got so many good ones inside here. So that was Wintermute. Show Me the Plan, send it in. No, Show Me the Plan, sent that one in. I already looked at that. Bellant Gukuk. Copy link address. Let's go see. Let's go see. Let's go see. All right. Oh, now we got a party. This is what I like doing. MacDBA says, does that even include the default trace? No, the default trace is tuned entirely differently. I don't recommend turning the default trace off. If you happen to read Aaron Bertrand's recent post on turning off the default trace, I'm fine when he does it. I'm not so fine when the rest of you do it. Technicolor DBA, feel free to remind me again when I go and check the next one. So, but I didn't miss you. I love you. I love your name. That's fantastic. Technicolor Dreamcast is awesome. All right, so this is Bellant Gukuk. Bellant, I'm going to call you Bell. Bell has an awesome server, and this is why I like doing these in public so that you can all... Boolant. Okay, so Boolant asks, has an awesome server that y'all can learn some interesting stuff from. In about 700 hours worth of uptime, his server, if you add these two together, has spent like 90,000 hours waiting on CX Packet and CX Consumer, which means that we have Parallelism Gone Wild Spring Break Edition. We have a lot of queries running that are going parallel, each of which probably have a whole lot of tasks in them. Boolant probably drinks a lot when he looks at these queries. So the first thing that I usually say is let's make sure that we set cost threshold for parallelism. It's 120 plus data warehouse. I assume that means 120 cores, lots of wide tables, and Vercare Max, 16 cores. Great, good job on setting cost threshold for parallelism and MaxStop. Now that you've set those to sane defaults, the next question is going to be what queries are going parallel and why? And to find that out, what I do is I look at the next wait type. The next wait type down tells the story of, are queries going parallel in order to read a lot of data or because they need to do a lot of CPU work, like crunching XML, shredding strings, etc., doing grouping, sorting. In your case, a ton of CPU waits, insane bananas CPU waits. In 700 hours, we've spent 20,000 hours waiting on CPU. So the way that the scheduling works is that a query's task will step on a CPU core. They'll say, okay, I got everything I need, ready to go. I got these pages. I need to scan them, do a grouping for the accounting department. He'll start working, and he'll work for up to 4 milliseconds straight. But after 4 milliseconds, he yields the CPU core. He says, all right, I'm going to be a good citizen. I read as much as I can, and I got a lot of more data, but I'm going to step aside for a second. So he steps aside, lets someone else step in. He yields the CPU scheduler. Would like to let the senator from Alabama have the floor. And then the clock starts. How long after he's used CPU for 4 milliseconds straight, how long is it until he can use CPU again? That's where we're going to scroll across to the right-hand side of this, and we're going to look at the third row. 13 milliseconds. Your server is screwed on CPU power. Like it may not be at 100%, but it's banging 50, 60, 70, 80% frequently during loads. Now, I always want to keep things in perspective. You said 16 cores. My laptop has 6 physical, 12 hyper-threaded. So you're effectively running your data warehouse on something not much bigger than my laptop. And I get it. It's probably Enterprise Edition. It's probably really expensive. But that doesn't mean that it's enough for these workloads. For every 4 milliseconds that they spend on CPU, they have to bail out and spend 13 milliseconds in line. You know what that's like. It's like you and your toilet paper, right? You got to go wait at the store in order to get more toilet paper. It takes forever. By the time you're done and you check out, you go to the bathroom, you use all the toilet paper, you got to go back in line again. Maybe that's just me. So in your case, it's easy to say, oh, I got to go add some more CPUs. But in your case, Boolant, here's what I would do in order. So Boolant, first off, you're going to run SP-Blitz. I'll do it this way. SP-Blitz check server info equals 1. And when that comes back, you're going to scroll way down towards the bottom, and there's going to be a power plan section. Nick says, is it worth mentioning how Parallelism took several hits with patches? The problem is that I can't fix it, though. That once you do those patches, I got to find you the route forward, and I can never tell people to uninstall the patches. So it's kind of like how when I was going to go into a rant about MaxStop 0, but I'm not going to do that here. It's I just got to find the thing that they're going to be willing to do that will actually get them across the finish line. But that's a good point, too, as well. So when you get SP-Blitz check server info equals 1, you scroll way down to the bottom. There's this line here around power plan. And Nick's true, and if you're not running anything on the box, you can also turn off hyper-threading. There are other things you can do. So the first thing that I'm going to do, I'm going to start with the easy stuff, and I'm going to go down to power plan. In here, you're going to see how fast your CPU cores are and whether or not you've got balanced power saving on. You do not want balanced power saving. You want high performance. And it's not just enough often to set it at the Windows level. If this is something like a VM, if this is something like, oh, thank you for Mittens the Killer Bunny. Oh, I appreciate that. That's very cool. No, if you didn't want to, I don't care if you do or not. That's totally cool. It's the first time anyone's ever done it for me, so I kind of have a soft spot in my heart for you. It's not enough to just set it inside of Windows. Oh, it's a VM in Azure. Oh. So the thing with VMs in Azure is you're probably not getting any kind of fast CPU speeds. Generally speaking, in Azure, you're going to get antiquated. There's tequila in the cup, exactly. You're going to get very antiquated CPUs, very slow CPUs. So you have an interesting separate problem. What you'll want to look at is how fast are those cores, and then just start having the honest conversation with management about our CPU cores are, say, 2 gigahertz. Everyone else is running on 3 or higher. Our CPU has already taken like a 40% hit. And when Nick was talking about patches around CPU security, you're going to have uglier kinds of patches than that because they want to make sure that you don't see anybody else's data. So what can you do? You can change. If it's a VM in Azure, you can at least change the power saving. I don't think it's going to help you one bit, though. I think it's going to be overridden at the VM level. So you probably want to just raise the flag with management to say, I don't have a whole lot of easy buttons at the hardware level. This is going to be really hard from a server tuning perspective. Then you're into SP Blitz Cache sort order equals CPU. You're going to run SP Blitz Cache and sort order equals CPU. I just want to give you a warning, though. In here, the warnings that you usually see, and anytime you go, because what this gives you is your top 10 most resource-intensive plans in the cache, sorted by CPU in this case. What you're going to see in the warnings, and every time you watch a query tuning video anywhere, almost all of us, when we tune queries, we're focused on reducing logical reads. We're focused on reading less 8K pages, but that's not the kind of tuning that you need to do. The kind of tuning that you're going to want to do is going to be around how do I reduce the CPU work involved in a query. It's not very intuitive to measure that. When I look at warnings, it's hard to know off the top of your head which warnings are related to CPU and which ones are related to reads. If you happen to have a live class season pass with me, so I'm going to go to brentozar.com/go/master servers. Over in Caligula, thank you. I appreciate it. That's very kind of you. Woo. So if you happen to have a live class season pass, go into the SOS scheduler yield module, and in there I talk about the specific warnings in queries that trigger this. And I'm just going to give you a list like brain dumped off the top of my head. So things like sorting, grouping, string manipulation, XML searching, cast converts in where and join, so like filtering by that, user-defined functions, and that's probably a good start. Heaps with forwarded fetches. So these are the kinds of things that you're going to be on the lookout for, Bulent. Normally when we think about making servers go faster, it's a lot about indexes and reducing reads. For you, it's going to be very different. All right, so that's Bulent, and we should, as one of y'all said, we should all pour one out for Bulent because that is pretty rough there, what he has to deal with. Now, who's the person that I skipped? Technicolor Dreamcast. All right, Technicolor Dreamcast. Let's go and get yours. So Technicolor Dreamcast says, let's see what we got here. Says, thanks, Brent. You're absolutely welcome. So Technicolor Dreamcast, if nothing else, you should take comfort in the fact that your server isn't as bad as Bulent's. Woo! Holy moly, I have to wash myself off with Clorox after that one. So Technicolor Dreamcast says 2014 virtual machine, 4 cores, 48 gigs of RAM, 150 gigs of total database size. Oh, so like a little smaller than my laptop. That's not bad. You're close, just not quite as good as my laptop. Now, the good news is, though, you really don't even need my laptop. Your server's not overwhelmed. In about 500 hours worth of uptime, the first one's completely ignorable in your case. The second one's CX packet. Parallelism, we talked repeatedly on here about setting your cost threshold and max stop at sane defaults, but I'm not worried about your CX packet. The numbers are fairly low. What your users are probably angry about, it doesn't happen all the time. This is one of those where it's only happening every now and then. When it is happening, what they're upset about is the blocking. So lots of queries. One query's taking out a lock, and then other people want that lock. It's only happened, though, for 23 hours out of 545. So the thing that I'm interested about in here is way over on the right-hand side. No, laptop's thermal throttle. Especially to address Nick's point, I have mine wrapped in a plastic case. Now, you'll notice it has vents on the bottom, but even still, I feel really dumb. I have turned off Turbo Boost, though, because I don't usually need 2 subscribers inside one. Oh, my God. Oh, my God. And yeah, I can't get past the stickers. I always think of my laptop as a passport. It shows all the stickers of places that I've been, and the laptop is only ever allowed to wear the stickers of the place it actually went. Like, I don't go and buy extra stickers and then put them on whenever I get a new laptop. So it's kind of fun. I keep my old laptop cases as kind of like a memorabilia of all the conferences and stuff that I presented at. So on yours, when you're waiting for a lock or when your users are waiting for a lock, it's only half a second. It's 474 milliseconds, which is not catastrophic. So sometimes what I see is people have things like standard edition and they're rebuilding tables and holding locks on those tables. I don't think that's with yours. I think it's just plain old, good old-fashioned locking, and it's just kind of in the background if it's only half a second. Where I would be worried is if you're like a seasonal business that's all of a sudden going to hit the gas in the summer and you're going to have way more workloads. Richie has a nicer solid state drive than I have. And that actually surprised me because I didn't remember buying him the 4 terabyte SSD. I was like, you son of a... So with yours, if you were going to hit the gas later, like if all of a sudden it was going to have higher workloads later, then I would worry. But in here, I probably wouldn't worry that badly. If you want to find more information about it, so this is for Technicolor Dreamcast, SP Blitz Index, get all databases equals 1. Look for aggressive indexes and read the URL. There's going to be a set of warnings around aggressive indexes. These are the indexes where the locking is happening. This doesn't mean the indexes are bad. People look at this warning and they're like, but it says create an index and I already have that index. Do I need to drop it? No, you need to read. This is a really hard problem to solve. That's also, and I mean, it's a hard problem to solve inside the span of I can't give you one line to fix it. But you can read it and you can totally tackle it if you read it. That's the struggle that I often run into with folks is that they just go, the indexes are aggressive and it scares me. Please hold me. And I'm like, yeah, no, you don't pay me enough for that, especially this day and age. Okay, so let's take a second to stop and thank our sponsor for this week. So this week's webcasts are brought to you by Quest Software. Quest is doing these totally free database days where it's a series of webcasts with me, Penal Dave, Janice Griffin, and we're doing all kinds of webcasts around how do you do performance tuning, read your weight stats, save money in Azure, avoid blocking, all kinds of fun stuff. It's all totally free. You can go sign up for it over at brentozar.com/go/database days. My first one up in the rotation is in about 2 weeks, and I'm going to talk through this exact topic, talking about measuring your weight stats, interpreting what they mean, batch requests per second, how to measure your total database size, basically how to get a feel for how your server relates compared to, say, my laptop. All right, next up, that was Technicolor Dreamcast. Now we have Gems Chems. Gems Chems. Let's see what Gems Chems says. So Gems Chems, move in. So Gems Chems has a Vaseline over the top of their screenshot camera there, or they're like drunk first thing in the morning, or maybe it's afternoon where they live, who knows. In about 500 hours worth of uptime, Gems Chems, wow, damn, y'all are like on fire with the subscriptions today. This is fantastic, woohoo. Gems Chems has number one weights hype in across the span of about 500 hours. You're talking about 400 hours of the time your server has been waiting on the app to digest the result faster. Now, this can be caused by a few different things, and I touched on it briefly with somebody else. I'm going to go just a little bit deeper inside here with yours. So Gems Chems. The classic async network I/O causes is one, app server far away from the database server, two, app server underpowered, swapping to disk, 100% CPU, three, app server doing row by row processing with each row, and then four, asking for more data than they need. And none of these, they're not really tunable from the sense of the SQL server's perspective. Yeah, there's a snowball's chance in hell you have a crappy network card, but that's never what this is. This is usually one of the things up four on the top. To diagnose it, what you do is take Atom Mechanics SP who is active, and you run it go 10. So you just run it 10 times in a row. I'll show you how it works. What I'm going to do is I'm going to cause async network I/O over from my own machine from DBO users, go 10. So I'm going to start a query on mine. Let's move this over into another window. So the query, just to make it crystal clear, there is no network involved here. I'm running a query against SQL Server from the SQL Server itself. So I'm going to start the query over on the right, and then I'm going to run, not from that database, I'm not. I'm going to get in the right database, and then I'm going to run it. Then I'm going to go hit SP who is active 10 times. And let's move around here so I can see it. So I can get it all beautifully in on my window, and I'm going to make it happen. Come on now, buddy. Happen at least once. This is going to be, there it is. Okay, perfect. So I'm going to hit stop over on the query over on the right and close it, and we're going to go see what you would see over in your own server. When you run SP who is active, and it won't happen every time, you're going to have to do it several times, just like I did, but you're going to start to notice a trend. And I'm going to put a few things on the screen here just so people can see it easier during the recording. What you're going to see, SP who is active will tell you what a query is waiting on right now. It doesn't tell you overall through time. You can get that, you just have to use different parameters, or you have to use SP Blitz Who. Where this is cool is it'll show you this query is waiting on that wait type we just talked about, async network I/O, and that means that this query, here's the query itself, running on this server, here's the server name and application where the query is coming from. This query is waiting because of one of those four reasons up above. Now look, don't just go hit this execute on this once and then go running directly into some poor user's office and go, you're the one who's the problem. What you want to do is look at this a few times over the span of a day or two. If you Google for how to log SP who is active to disk, there absolutely, Tara Kaiser and Kendra Little both have great articles on how you go about doing that. You want to get a feel for this one first because you may have outliers now and then, but what you're going to notice is that a lot of the queries are going to be coming from the same place, from the same user, and that's the thing you want to go and focus on. Help them fix these things up at the top for. I want to say there was something else in yours that I was interested in too. The other two, so the next two underneath it, your server's got a storage bottleneck problem in terms of waiting to read data pages from the data file. Users are asking for data that's not cached up in memory, so your storage is having to do I/O in order to read an 8K page. It's there. It's not a huge wait. It's like 260 hours out of 500. But the storage is really, really fast. When you're waiting on storage, it's only 1 to 2 milliseconds. That's great. It's probably all solid state, super quick. If you wanted to fix that, it's not actually a storage problem. The thing that it is and I'm just going to mention these. This shouldn't be the first thing that you go down, but when we talk about your page IO latch, what you would do is number one, tune indexes. You'd run SP blitz index, get all databases equals 1, then focus on the high value missing indexes. 2, tune queries doing the most reads. That's SP blitz cache sort order equals reads. And then 3, add memory. And that's the order that I'll usually do them in, is this exact order right here. Because, of course, management thinks that our time is cheap. So they like number one. And, well, they think that your time is cheap. They know my time is expensive as hell. But number one, except when I'm on Twitch. Then I'm on Twitch. It's free. Except for those of you who subscribed. Thank you very much for that. I appreciate that. So in here, these two are effectively free, whereas the one down on the bottom, that one costs money. All right, so that was Gems Chems. Next up is Juicy Ponin, except I'm sure it's J Usaponin or something like that. It's punctuation is everything. J Usaponin, let's see how yours looks. So you've been up for about 270 hours, about 10, 11 days. So that's good because I've got enough detail in there that I can make sense out of it. Oh, you were even all ready to go. I believe that's huge. Usaponin, were you to put it in? Oh, look at you. I'm so good. I thank you for having your details all ready to go right at the moment that I asked. SQL Server 2016, not the latest cumulative update, unless it's Service Pack 2, but it's okay. 4 cores at 2 gigahertz, so it gets smoked by my iPad. 128 gigs of RAM, maxed up as 2. Okay, I like your settings there. That's not so bad. In here, I make a lot of iPad and laptop jokes, but your server is appropriately provisioned. You don't need more than 4 cores. You have lots of RAM. You're totally fine there. Yeah, you have slow cores. They're not a bottleneck for you. That's totally okay. In here, you've set cost threshold and max stop at numbers that prevent page or CX packet from going out of control. So you did good job there. In your case, the top 3 basically mean that queries are going parallel because they need to either read a lot of data that's not cached in RAM or they need to do a lot of CPU work. On yours, what I would do is, out of curiosity, your storage is great. Your storage isn't bad at all. In yours, so Jay, I'm going to say that you would go through in this order. And I'm going to do this just so that you get a little bit of color coding there. And then here. Yours, I would absolutely not add memory. I'm going to take that away there. And that's perfect. So those are the 2 things that I would do on yours. The other thing that I would do, because your weight stats are fairly low, or that your server's not overwhelmed, is I would also start having a conversation with the users about, you tell me what you think is really slow. Because one of the drawbacks with weight stats, especially when they're over time like this, across the span of 10 days, is that they also include your overnight times, your index rebuilds, your updating of your statistics, your backups, all that kind of stuff. I can easily imagine a scenario where all of these weights were during your maintenance windows, like overnights, during the weekend, full backups, CheckDB, etc. Which also, those queries will show up over in tools like SP Blitz Cache. Okay, so let's close out of those, get my screens down to a more reasonable number. That was the one after Gems Chems, that was J. Okay, so, Gems Chems asked a question and I skipped it. If the vendor requires max stop 1, is cost threshold for parallelism still evaluated? And I'm going to talk about this for a second because there are probably several of you on the call who could stand to hear this. So there are 2 settings around parallelism: cost threshold and max stop. Cost threshold dictates how big a query has to be before SQL Server will consider parallelism. Then there's max stop, which is how parallel can queries go. What you may want to think about is when the vendor says, it's absolutely got to be max stop 1, queries can never go parallel. What you might want to think about is just setting cost threshold really high. Set it at, like, say, 500. So that way, most of the vendor's queries, they'll never know. Those things are still going single-threaded. But when a query's cost exceeds, say, 500, like CheckDB or something else that's massive, rebuilding a big index, You want that sucker to go parallel if the cost hits that high. So I've been known to, even on boxes like Dynamics AX or SharePoint, where they say, it's got to be maxed out 1. I'm like, okay, don't worry your pretty little head. And as soon as the support call is over, I'm going to set maxstop to just a normal realistic number to let queries go parallel. But I'm just going to set cost threshold so high that the vendor's queries never hit that threshold, which is challenging, of course, because things like SharePoint and Dynamics AX can write truly horrific queries. Now let's see here. Next up is, we got all kinds of good ones today. Let's see here. Next up is 530 days of uptime. So let's see. Who else did we hit? We got tons of them in here. Jump scam, stress opponent. Okay, so next up is, how did I miss? Nope, that one's good. That's the music. Graphic www, and then Greg. Greg, you are next. So graphic says, that's interesting. Graphics had about 1,000 hours worth of uptime, and in that time, 52,000 hours. For every 1 hour on the clock, 52 hours of time waiting on database mirroring. So for everybody, it's high Brentos are. For every 1 hour of time on the clock, you have 52 hours of time spent waiting on this. That is a big deal. There is sweat pouring off your SQL server. He's nervous as all hell because he's constantly doing inserts. Brent is avoiding real work. I don't know that I've ever found real work. In this thing, every time that we do an insert, update, or delete, we're having to wait 140 milliseconds in order to submit our transactions over to the secondary. So we do an insert, update, or delete on the primary or the principal in mirroring terms. We push that transaction over to the secondary, the mirror, write it on the secondary's transaction log, and send that confirmation back over the network. 140 milliseconds of average time. That's like we've got that old man in the sea writing calligraphy again. So we're etching our transactions on the finest parchment and then handing them over to a Pony Express rider who's jumping aboard his horse and riding across the country. 140 milliseconds is a hell of a long time to add to every single transaction. So what do you do to fix this? In order to reduce this, what you can do, the first thing that I'd ask is, are users angry about the speeds of inserts, updates, and deletes? Because they're a true story. At one shop that I was in, they had just moved from really crappy storage to amazing storage, and they're like, our transactions are all instant now. And I'm like, the hell they are. But to them, 140 milliseconds just wasn't that big of an overhead. If they're unhappy with inserts, updates, and deletes, very often the way that this hits is you have an application that sends changes one row at a time, does one insert, update, and delete at a time, and then it's waiting for each one to come back. Then it's going to be intolerable because you can only do like 8 a second. If they're upset with that, if they're not happy with the speed on the mirroring, here's what you go and do. Number one, look at wait stats on the mirror. So you're going to do the exact same thing that you've been doing on the primary, but you just go over on the secondary and you go run this, since startup equals 1. What you're looking for, and don't paste it in again, just because, of course, I want to hit as many people as I can out of here. What you're looking for is that secondary writing to disk as quickly as it can, or is there something else going on? If you go in there and you find out that write log on the secondary is like 100 milliseconds long, that's because the secondary has really crappy storage. What you may consider doing is moving the secondary to be much a faster local solid state, for example. If the secondary says, I'm able to write all my changes within a couple of milliseconds, then the problem is more likely the network bandwidth between the two boxes. That's when you have to get your network teams involved and start deciphering how much bandwidth you can actually push through there. The last thing that you could do is, if people don't trust you, people don't believe that mirroring's really the problem, set a time window when you're going to temporarily drop the database into asynchronous. You're going to temporarily switch to asynchronous mirroring and watch how different the user experience is during that time. It's going to be like night and day, absolutely amazing. One other thing that I'm going to say to you, just because I've got you here, given that your mirroring weights are so terrible that 140 milliseconds apiece, one thing you just probably want to ease back on is things like index rebuilds. When your storage is that slow to respond across a secondary, you can't afford to rebuild indexes very often. So make sure you're only rebuilding indexes at most weekly, like at most weekly. All right. So there is that one. That was graphic. Next up is Greg, and after Greg, it's SirBio77. So let's see what Greg's got here today. Greg is a regular around here, so I like Greg. I mean, it's not true because there are people who are regulars that I don't like. So that's not true. I think I pretty much do like all the regulars. Greg has in about, let me move this thing around here. So Greg has, the top weight is ignorable because it's just about 1-to-1 with clock time. I'm not too worried about it. The second two indicate that we're probably on an older version of SQL Server, either unpatched 2016 or 2014 or prior, and queries are going parallel to read a lot of 8K pages. This is especially true because of the fourth weight inside here, latch EX. What this is that SQL Server wants to read an 8K 2008 R2. Take it to Antiques Roadshow, Greg. That's not true. I'm fine with 2008 R2. It's totally okay. So when SQL Server needs to read an 8K page that's cached in RAM, the first thing it needs to do is just go take a quick look. Is this thing locked? No? Okay, I can read it. What about is this locked? No? Okay, I can read it. That lightweight lock is called a latch. And it normally is so fast, especially because we know that the page is in memory, normally it's so fast, it's not a really big bottleneck for us. But the combination of those three means that I have queries running very frequently, doing a lot of reads. Here's how you're going to catch it. So on yours, what I want you to do is run sp-blitz cache, sort order equals reads, also run sp-blitz cache, sort order equals executions, then run sp-blitz index, get all databases equals 1, and look at high value missing indexes. You're going to see a common thread between all three of these. You're going to see a query that runs all the time, and it scans tables, and it desperately needs an index. And you might have the reaction of, oh, we know about that query. That's a back-end process. It doesn't matter. Oh, no, it does. It actually does. Because what happens is SQL Server bases its choice of which 8K pages it wants to cache. It bases that choice on the pages you query the most frequently. So this big, ugly, nasty query that runs all the time, maybe it's a system process, maybe it's the front page of the website, whatever, this query that runs all the frickin' time, it's ending up pushing everybody else out of the cache. Now, in terms of questions, I'm not just going to do random Q&A. Today, we're focusing on weight stats. I'll do random Q&A on other live streams. So what you want to do is either tune the indexes for this, or of course there's always cache it at the application layer. I'm a really huge fan of that, but find out what you can do to improve that. I think you're going to find that there's a query running way more often than you expected, and it's just scanning too much data. Next up, SirBio. And after SirBio, I will take a bio break, for example. Oh, that's true. That's so true. It's funny because it's true. Are y'all still running that on the primary? I think you're, yeah, you have to run it on the primary because it does writes. Yeah. Whew. Oh, that's terrible. Oh, SirBio, your server just took a bio break. So your server's only been up for 2 hours. And unfortunately, you can't just tell anything during 2 hours. It just, there's not enough uptime. There's not enough workloads. And I wouldn't want to put any faith in that. Oh, is it running from secondary? Oh, yay. Oh, that's good. So a true story. Chat time. So true story. I have a client with, and I kid you not, 13 always-on availability group replicas distributed out in a big old distributed availability group, all kinds of high availability redundancy. And they are beating the snot out of the primary. I mean, just every query, every report, people are allowed to run SSMS directly in production, all this. And they had never even heard of the concept of readable replicas. I'm like, how do you spend this much on licensing and not hear that? So we had that discussion. Here's how a readable secondary works. Here's how you can query the secondaries. And they were already paying licensing anyway for all kinds of these servers. It was just one of those eureka moments where they basically were like Oprah giving away cars. They were like, you get a replica and you get a replica. Everybody gets a replica. And all of a sudden, all their problems went away because everybody had their own dedicated server to go beat the daylights out of. Sounds like an upgrade nightmare. When you have a hammer, everything's a nail. When you're Stack Overflow, everything's an upgrade problem. Y'all have the same, distributed availability groups. Woo! And a brief shout out to Taryn, one of the DBAs the DBA over at Stack Overflow. So Taryn blogs over at TarynPivots.com, and she shares their upgrade problems right out publicly so that y'all can go see the kinds of challenges that a big site like Stack Overflow runs into. It's really fun to watch. Okay, so SirBio, yours, and just to drive home the point in there, you need a lot more than 2 hours worth of uptime, so just try not to reboot your SQL Server next time. We will take a short bio break here. I will keep going. I'm just going to go refill my coffee, and then when we come back, it'll be like 2-3 minutes, and when we come back, I'll keep going on your weight stats. So I will see y'all back here in 2-3 minutes. Mute myself too. So let's see here. So back up and at 'em. So welcome back, everybody. Now I'll go in and dig into some more weight stats. Feel free, if you're just now watching and you want to get in on showing your weight stats, by all means, go for it. You can follow the instructions that I gave earlier out on the blog post, and I'll go. Like my first appointment today, the first call that I have is all the way until like 1:30 p.m. Don't feel bad for me. I did this on purpose. I like schedule sanity days inside my my schedule because I want to make sure that I'm able to go off and do the things that I love, and this happens to be one of the things that I love. All right, let's see here. Now, next up. So when last we met, we were doing Sir Bio and his Sir Bio break. Next up, we have Carudo. So Carudo, let's take a look at Carudo. Makes like seafood Carudo. Carudo has SQL Server Web Edition, SQL Server 2016 on RDS, 4 cores and 16 gigs of RAM. Okay, all right, so this is a little bit different. So you're on, you said 2016, you need to patch. You're on an unpatched version of RDS. You want to make sure you get to control what version you go to, what patch level that you go to. Uh-oh, says, oops, did I post the wrong one? Is that Carudo, or was that, who said that? No, that was Sir Bio, okay. So Carudo, where the hell did it go? Oh, well, whoever. So Carudo, you want to make sure to patch. RDS lets you control the patch level that you go to. Just make sure you go to a current patch level because you're pretty far behind. Having said that, in 1,600 hours worth of uptime, which is admirable, you've got about 800 hours worth of parallelism weights. You do get the ability, I don't know if you've done it, but you get the ability to set cost threshold and max stop in RDS. They're called parameter groups. If you search for SQL Server RDS parameter group, you can set parameter groups that will be used on startup. The options groups, yep, there you go. So now, after you set that, just to make sure that you set cost threshold, and man, it sure doesn't let me change it. Well, I've actually heard there's someone else on the call who's struggling with that problem. So it won't let them change it. Okay, that's cool. And I'm not stressed out. Like your parallelism weights aren't really high, so it's not catastrophic. When queries go parallel, they're going parallel to read a lot of data, and that data isn't cached in RAM. On some of the other parallelism notes, you've seen me catch people who had latch EX in their weights, and you do not. Your queries, it's not that they're very frequent and they're constantly scanning RAM. Your queries, stuff's not in RAM. Whenever they do run, the stuff's still not in RAM. And I bet, I'm just going to kind of guess, I bet your page IO latch weights, the average milliseconds per wait, I bet they suck. Because cloud storage is typically pretty slow. I'm a gambling man, so I'm going to say that when we scroll across over to the right, I'm going to gamble that your page IO latch weights are at least 50 milliseconds on average. Usually Microsoft likes to say that over 20 is poor. I'm like usually 50 to 100 is poor to me. Let's scroll across and see. Whoa, you went for like provisioned IOPS. Oh, you're rolling in the bucks there. 3 milliseconds per wait is fantastic. That's absolutely wonderful. So with RDS though, you're in a tough spot. If you want, it says they're not provisioned. Oh, must be using ephemeral solid state, I'm guessing. That's just phenomenal. So the problem with EBS is the problem with RDS is that if you wanted to, general purpose SSD, yeah, okay. So the problem with RDS is that if you wanted to reduce those page IO latch weights, it's going to be so expensive in terms of memory, and it's going to be so expensive in terms of provisioned IOPS. What I would look at is, can I tune indexes and queries in order to reduce the number of table scans that we do? So I've said this was from, I want to say Greg's. Yours, you don't need reads. This is the only pair that you need right here. You want to look at the queries that are doing the most reads, and then your high value missing indexes. So that'll be the place where I would go to for you. Normally I'd say number 3, like in the grand scheme of things, 3 is add memory and 4 is tune storage. Up in the cloud means throw dollars at it. Neither of those really make sense for you, I think, until you've really exhausted the first couple, because you'll have much bigger bang for the buck over there. Just going to mention this because I got a real bad feeling about this. Let's go back and look at your weights. Boy, you know what I don't see on there? It's database mirroring or always on availability groups. I bet you pasted the screenshot from a friend's server. It's probably not yours, but tell your friend that they have a single point of failure here up in the cloud. They don't have a mirror or a secondary, which means that when, not if, but when the RDS instance fails due to an EC2 problem, you're gone for a while. Like this business is downtown Julie Brown. How old am I that I made that reference? So just be aware that you're kind of running without a parachute here, or running with scissors into a parachute. So just be careful there. All right, next up, let's see. Next up, we've got, says wubba wubba wubba. Goodbye, God bless. So let's see here. What else we got? Next up, I'm going to scroll way up. Where the heck did we go? So I haven't hit... Toefrog was here. Toefrog, you were here the other day. You already did one, Toefrog. So we did Surbios. We did Carudo. Next up is Hanny Helmy. So we'll do Hanny Helmy, and after Hanny Helmy, we're going to do Bavesh. So Hanny Helmy and then Bavesh. So Hanny Helmy, here's yours. Drum roll. Hold on, that's not right. I didn't quite get Hanny Helmy's right. Let me copy that. Oh, Hanny Helmy, you put extra stuff inside yours, I think. You put extra stuff inside the link. Let me try to chop that off and see if it works. No, Hanny Helmy, if you get time, check your link again. Oh, no, you sent me the download link. Ugh, Paint. What the hell? Ugh. No, let's edit this here. Let's edit this and try and get it right here for your own being. This is the story of a presenter's life. I give y'all one instruction. All you have to do is the one instruction, and you'll get free consulting. And you can't do the one instruction. I swear to God. So Hanny Helmy, inside yours. God bless you. You used just the wrong link. It's okay. Don't freak out. So Hanny Helmy, inside yours, your server's been up for 316 hours. In those 316 hours, basically for every hour, you've spent about 2 hours on the clock waiting for parallelism. Now, yours, in the past, in other instances, I've been like, okay, here's what you want to do around parallelism. But I'm going to take a detour on yours for a second. You have header sync commit down here and header flow control. What this means is that you have a sync availability group, and it's hardly causing you any pain at all. The overhead of a synchronous availability group isn't that big of a deal for you, indicating you've done a good job of tuning your infrastructure, cloud, whatever, to make sure that the commits happen as quickly as possible between those two replicas. That's kind of awesome, so just good job there. The combination of number 1 and number 3 indicates that you're a lot like the person that I just talked about recently, where queries are frequently going parallel, but they're just reading 8K pages in RAM. So for yours, what you want to do is this and this, sort order equals executions. Because I bet you're going to find a query that runs all the time that you weren't really expecting. And this query is doing big, huge table scans, reading lots of data. The other thing that I think you might have like an N+1 bug in the application, or a bug in the app where it's running a query every time it needs to say show the home page. Because you've also got async network I/O waits in here, meaning that the app can't digest the results fast enough. Sometimes when I see this particular combo, it means that like there was a query on the dashboard that everybody forgot about, and it's running over and over, completely uncached. Maybe you're going to find that query just shouldn't be run at all. You can tune it on the database side by adding the appropriate indexes to it or whatever, but I would probably just start there. Make sure that the query actually needs to run. All right, so that's Hanny Helmy. Next up is Bavesh. So after Bavesh, the next one's going to be Jack LT, Jack LT. So Bavesh, let's see what you've got over here. Bavesh says, I followed the instructions. Everything's in the right places. So Bavesh has about 654 hours worth of uptime, and in there about 6,000 hours worth of parallelism waits. You're absolutely welcome. 6,000 hours worth of parallelism waits. So basically for every hour on the clock, you're spending 10 hours waiting on parallelism. You've also got a little bit of an undercurrent that's a lot like the last one I discussed, but you've also got some CPU pressure in here. It's not terrible. CPU's not running 100% on the box by whatever, but you kind of have two different problems. Because Latch EX and Parallelism are so high, Bhavesh, for you, I'm going to say the first thing that you want to do is set CTFP and MaxDOP to sane defaults. And that I cover over at brentozar.com/go/cxpacket. After that, then go do the other things on this list. For you, I'm not sure that executions is going to be as big of a story, but definitely focus on this one and then this one as well. All right, that was Bhavesh. Next up is Jack LT or Jack IT. And then after Jack IT, I'm feeling generous, so I'm going to do Tofrog, even though I saw you in here just the other day. It'd be funny if it's the same server and you're like checking to see if you get the same advice or not. That would be kind of awesome. All right, so this is Jack LT. So Jack LT has about 100 hours worth of uptime. So this is only like 4 days. So is that Jack LT? It is. So Jack LT, thank you for having your info ready to go. That's kind of awesome. I didn't even think about asking for that, and I'm going to have to do that every time now. So Jack LT says SQL Server 2016 Service Pack 2, 2.5 gigahertz, 16 cores, 64 gigs of RAM, AWS VM. Well, technically AWS doesn't want, I don't think they offer one that's exactly 16 cores and 64 gigs of RAM. I think it's, well, maybe they do. It's been a while since I have. Okay, so in yours, did you say cost threshold? No, you didn't. Okay, so Jack, if you want, get cost threshold for Parallelism and MaxDOP, because you have Parallelism gone wild. This is 8 dual core. You have Parallelism gone wild Spring Break edition. You have Parallelism going wild and crazy, reading lots of 8K pages that are cached in RAM, and even having contention for 8K pages that are cached in RAM. As in, like, objects want to lock things. It says MaxDOP 0 and cost equals 30. Okay, yep. So the big problem that you want to change is your MaxDOP. Queries are going parallel across way too many cores, and there's an overhead, especially when SQL Server doesn't balance that work correctly, and it's not balancing the work correctly across all of your cores. So numero uno for you will be that setting cost threshold for Parallelism and to sane defaults. Your MaxDOP's okay. I want to say your MaxDOP you said was 8. No, it's the other way around. You said your CTFP was 30. I'm okay with that. Usually you'll see me quote a range of between like 40 and 70. I'm okay with 30 though. MaxDOP is going to be the big one for you. Now, if you read, so just a second here. So when you read my post or Microsoft's knowledge base article, we're both going to say effectively the same thing. Set it up to, there's lots of gotchas in here, but up to the number of cores in a processor. And you just said you have 8 dual-core processors. That's only what it's presenting to you as in the VM. You can actually configure that in AWS. You can configure how many cores are shown per processor. So don't get too hung up on that. Don't think that it needs to be 2, because that would be too big of a drop. If your SQL Server has 16 cores in it, so if your SQL Server has 16 cores in it and you drop it all the way down to a MaxDOP of 2, users are going to freak out. Users are going to be like, oh my God, queries are running way slower than they normally would. So I wouldn't go from 0 all the way down to 2. What I would do is go down to like 8, just to gradually start to get some of the unnecessary parallelism off there. But I don't think 2 is the right number. So now, after you do that, I'm going to say to 8 in your case. After you do that, what's on the screen here is picture perfect for you. You have a query that's running very frequently and just scanning 8K pages up in RAM. Your storage is fine, your CPUs aren't a problem, but you want to find this query that's running all of the time, scanning memory, and you're going to have a eureka moment going, oh, I just need to tune that one thing and I'm done. Or maybe it's 3 or 4 things. All right, so that was Jack. Let's see. Next up, going through the list. So next up is Tofrog. After Tofrog, looks like Hanny Helmy sent in another one. We're just going to do one per person today, though. So after Hanny Helmy after Tofrog will be LGR SWE. So Tofrog is up first. Tofrog, then LG SWE. Tofrog, your server. Oh, that's kind of odd. That's interesting. Look at that before I say anything. Oh, wow, that's really, oh, cool. Okay, so Tollfrog, this server is CPU bottleneck, but it's not 24/7. There are brief bursts where all hell breaks loose. So remember how earlier I said that queries step on a CPU core and they go, here, I got all my work, I'm ready to start doing some reads. And they use CPU for 4 milliseconds straight, and then they gracefully yield the CPU to someone else. They say someone else can step in now and do reads, and they go to the back of the line, kind of waiting to see when their turn is. Then they get back on the cores and start work. So what this means, what this top weight SOS scheduler yield means, is that queries are using CPU for 4 milliseconds, and then they're waiting for 2.6 milliseconds. So you can kind of think of it as that queries that need CPU are running about a third slower than they could if there was no competition for CPU at all. However, the number of hours isn't that high. It's 37 hours out of 116. And you might be saying, Brent, that's 1/3 of the time. No, it's not. Because your SQL Server has multiple cores and all of them can run multiple queries at the same time. It wouldn't be unusual if this server was really hustling 24/7. It wouldn't be unusual to see this up in the hundreds or even thousands of hours worth of SOS scheduler yield weights. So for yours, even though it's not 24/7 in terms of CPU busy, that's the thing that I would go and focus on, is queries burning the most CPU. And you may have noticed that in some of the other ones, ones in here, I said SP Blitz cache sort order equals CPU. And I said you want to tune for things that cause high CPU usage, which isn't necessarily the things we usually think about in terms of logical reads. For you, because it's not happening that often, it might actually be out of the plan cache. So just pay very close attention when you run SP Blitz cache. In the second result set, there's going to be a warning that looks like this down here. If your warning is priority 1, it means that your SQL Server has amnesia and it's not able to cache that many query plans. You may only be looking at recent history. So just read that line, copy paste that URL out, and then go read it for more information. Because I wouldn't want you barking up the wrong tree when the queries that you see in that top list aren't actually the ones causing your CPU problem. All right, next up, LGR SWE, and then after that we'll hit J Patella. So LGR, let's see here. What do we got here? Ooh, Parallelism Gone Wild again. Parallelism Gone Wild Spring Break Edition. So in the span of about 500 hours worth of uptime, your server spent about 5,000 hours waiting on Parallelism. The good news, your server's not overwhelmed. Nobody's seeing 100% CPU, but you have unnecessary parallelism going on. Queries are going wild and crazy with the parallelism to read all kinds of 8K pages, that probably doing table scans of stuff that really we should just be doing index seeks and bombing out for. So on yours, LGR, you definitely want to do the set cost threshold. So set CTFP and max DOP to sane defaults per that post. BrentOzar.com, go CX packet. And then after that, the next thing will be SP Blitz index, get all databases equals 1. Look for high value missing indexes. And then SP Blitz cache, sort order equals reads to find the queries that are causing those high value missing or generating those high value missing indexes. Like I talk about in my index tuning classes, remember, those indexes can be wrong. Those indexes are a byproduct of building execution plans. They're not SQL Server's main job. It's just a comma-delimited list of columns to consider indexing. All right, J. So J is next, I believe, or did I just do J? Let's go look at J's. And J's is, no, J's is different. So we'll do J's now, and then next up is Q-Tekla. So let's see what we got here for J's. So J, Patella J, yours, the server's been up for about 700 hours. The top one's ignorable in this case. Your 1, 2, 3 combo indicates that you're on either an unpatched version of SQL Server or like an unpatched 2016 or a 2014 and older. everything that I just said, let me look at one other thing. Yeah, everything that I just said in the last round applies exactly to you as well, Jay. It's a mirror exact copy there. That's where you go get started next. So next up, Qtecla. So Qtecla, let's go copy that out. And then after Qtecla, top 5 Survivor players. Oh, top 5 Survivor players of all time. Oh, my number one would probably be Rick. Rick from one of that most, 38 or 39. The Courtney Yates, who I think was very underrated. Courtney Yates was a blonde woman who sucked at challenges, but was very good at being like the evil parrot on your shoulder that would tell you things to do that were kind of bad, and you would end up doing them. Parvati was another one that was in that very same way, that she had a way of manipulating people to get what she wanted. Rob, I absolutely adore Rob. What the hell's his last name? Rob has the construction company. It's an Italian last name. He's in Jersey. Anyway, Rob, everybody know Boston Rob. Boston Rob would be up there. Is there anybody else? I really liked Sandra because she was just no BS. She's like, if I'm going to vote you out, you're going to read it. It's going to be my body language. It's going to come straight at you. I'm going to do what I can for you, but at the end of the day, you're out. So it's interesting that I pick a mix of people who are physical players and then also who are mental players. I'm a Survivor fan, also Project Runway, Making the Cut. I like a lot of really terrible, bad TV. Oh, it's awful. So let's see, Qtecla and then no Joe. Yeah, no Joe. Yeah. I can't even remember Joe. Who was Joe? I'm not going to go Google now. So Qtecla, and then the next one that I'll go cover is top two WYO. So let's see here, Qtecla. Oh, good. Oh, I almost want to. Oh, I want to close it. God, I run this webcast, and I really could close it, I guess, if I wanted to. Oh, Qtecla. So you're the first person in here who has to deal with really bad locking weights. And they're not really bad. Across the span of 9,000 hours, which just means you need to patch. You're way past the time where you need to patch. But you need to patch, but and the async IO completion. So the blocking, that top one, frick. The top thing, 9 seconds on average when we're waiting for weights or when we're waiting for locks. We're waiting 9 seconds on average, and it's not like it's happening every now and then. It's happened, several 100,000 times. So your users are unhappy. Your users are super unhappy. So what you're going to go do, so this is for Qtecla. What you're going to go do is SP Blitz Index, legacy system. I always love the word legacy because it's like something you leave behind, and you should probably leave that system behind. SP Blitz Index, get all databases equals 1. You're going to look for aggressive indexes warning and read the URL because that one's kind of complicated. The other thing that you're going to do is SP Blitz cache sort order equals duration. You're going to look for long running low CPU warning. What this, and I got to write this out because people take screenshots all the time, and I want to make sure you get it in the screenshot. These are the blocked, not blocker queries. What this sort order tells me is go find me the queries that run the longest time, and in the warning column, the only queries that you care about say long running but low CPU. What we're analyzing there inside SP Blitz cache is we're saying this query took 2 minutes in order to run, but it only did 3 seconds worth of CPU work. The classic scenario for that is blocking. This query had to wait forever in order to run, but it was just blocked the whole time. So those are the two places that I would start. I could make an argument that you would also look at SP Blitz Index, but that's only deadlocks. I actually don't think you have a deadlock problem, because deadlocks solve themselves within 5 seconds. Every 5 seconds or faster, SQL Server's deadlock monitor wakes up, puts a bullet in the query that's easiest to roll back. Your average lock wait times were up in the 10-second range, which indicates that they're going probably longer than the deadlocks are going. So you may have deadlocks, it's just not the biggest thing. Oh, Telefrog says, I was here yesterday watching, but I didn't submit your imager. Oh, because you were shy. Okay, all right. In that case, let's go back to Tofrog screenshot. We'll copy Tofrog screenshot, and then after Tofrog, we'll go do top 2 WYO. So Tofrog's is, oh, okay, so Tofrog, you didn't have anything to be ashamed of. Your server's okay. So Tofrog, in yours, you only have like 115 hours worth of wait stats. 2012, okay, good, you're patched, 8 cores, fast CPUs. You're right up there with my laptop. Not quite as good as my maxed up 1. What the hell? Okay, anyway. Okay, so I don't think there's something going on, and they're interesting, because you said maxed op equals 1, but you have CX packet waits, which would indicate the queries are going parallel. When you run an option max stop hint, you can actually hint higher than the max stop at the server level. So maybe somebody's hinting, but there's something interesting going on there. It's only about 4 days, 5 days worth of waits, so I'm always hesitant to judge something on that short, but it is weekdays, so we probably have a good chance of reasonable stuff inside here. Your El Numero problem, both number 1 and number 2 are vaguely related to, oh, you got a lot of interesting stuff going on here. Number 1 and number 2 are both vaguely related to CPU, but I also see latch waits. And when you talk about max DOP and these other things, I think what you really need is a basic setup on SQL Server. So if you search for Brent Ozar setup checklist, go through my setup checklist, and it's totally free. You can go download it as part of our first responder kit. You can go download it, walk through your SQL Server setup. I have a hunch that you're missing also things like multiple TempDB data files, for example, that you may not have all of your TempDB data files set up quite correctly, also with what I'm seeing there. The server isn't on fire, but just overall, I would just start with a simple basic setup checklist. Okay, so, and you shouldn't feel ashamed. There's nothing wrong with it. It's totally okay. Next up is top 2 WYO. And then after top 2 WYO, we will be hitting GH in van, which I can only assume means in Vancouver, not in the back of a free candy van. All right, let's see here. So we'll paste this out here and paste. Top 2 WIO says SQL Server 2012 CU19. Ooh, very nice. Good job on the patching. And then 64 gigs of RAM. It's a VM. All right, cool. So almost identical to my laptop. That's not so bad. Oh, good news. Top, you can go take, this is Vancouver, BC, not a van. Good news, you can go take the day off. Your work here is done. So in a roughly 340 hours worth of uptime, no one's probably complaining about this because the server's only been waiting like altogether like 40 hours on the top 2 real waits there, CX Consumer and CX Packet. I don't think people are angry about the performance on this server. For the most part, it's sitting around bored playing tiddlywinks. Because you were so good at immediately pasting in your server's config, I bet you also set cost threshold for Parallelism and max DOP at sane defaults. So in here, because the weights are so low, what I would actually do is pivot to the users and say, you tell me what you're having problems with, and get the queries from them that you want to go and tune. Because otherwise the server's not in bad shape. And sometimes that's what's valuable about stuff like this, is that you hear that the server's not on fire and you go, okay, I can go back to focusing on other problems. Okay, so we'll stop here for a second and give a shout out to our sponsor for this week. Our sponsor for this week is Quest Software. Quest is doing a set of totally free training webcasts called Database Days. It's me, Penal Dave, Janice Griffith, and we're all getting around and talking about weight stats, performance tuning, index tuning, query tuning, Azure SQL DB, all kinds of stuff. It's all totally free. You can sign up for it over at brentozar.com/go/database days. And my next one is coming up in about 2 weeks, where I'm going to be talking about how to measure your SQL server, how you know if a car is fast, and in related, how do you know if a SQL server is fast, and then what actions you want to take next to go and jump into performance tuning more. So thanks again to Quest Software for making this possible. Several of you are thanking me as well. Thank you. I appreciate it. You're welcome. Let's see here. Next up is, we went past GH and Van. Next up is, oh, Frozen Swede gave me props again. Thank you. Jay says, thanks. You're absolutely welcome. Y'all are thanking me like I'm about to die. Holy smokes. That's kind of scary. All right, so I'm going to do, because we're coming up at like 10 minutes left, I'm going to work from the bottom up. So any of you who still haven't hit your weight stats, feel free to go paste them into Slack now. I'll do them up until maybe around a little bit after the hour. Sir Bio said he pasted the wrong one, I think, if I remember right. So let's go take Sir Bio's next one and see if that's better. No, Sir Bio, that one is bored out of its gourd. Drop table DBO students pasted one. Let's go see what drop table DBO student says. So, dropped BTFP says, how about this one for 2019? I don't know what how about this one is. How about this? Ross says surround music is a bit loud. Okay, sure, I'll turn it down just a little bit for you there. So turn that down just a little bit if I can get the button right. Okay, so didn't do mine. GH and Van, so what I just said was, if you have a screenshot to do, go ahead and paste it in. We're now at the point where we have a huge amount of chat messages. I just can't go back and forth all the time. Just paste in one if I haven't hit it yet. Remember, only one per student. Clunky says download FFZ and enable audio compressor. There's a compressor built into Streamlabs, so I can actually play around with that inside Streamlabs. It's just that there's only so much I can set up, with SQL Server and Streamlabs and all every single time I do a stream. So 3,000 hours, so let me just pop back and see. Drop table DBO students, about 3,000 hours worth of wait time and 36,000 hours worth of CX packet. For every hour on the clock, we're waiting like 12 hours on Parallelism. You have Parallelism Gone Wild Spring Break Edition, especially with the 3,000 hours worth of latch waits. Your server is constantly scanning things up from RAM. Now, there's also a subcurrent of CPU and storage issues, but the big thing by far is I worry about queries that are running very frequently, going very parallel to scan lots of pages in RAM, and we just need to do a little bit of index tuning. So for that, if you want, what you want to do, let me go back over here because I think I've got this beautiful. Okay. So this is what you want to go do. You want to go set your cost threshold for Parallelism and max stop to your sane defaults, and then get all databases equals 1, looking for high value missing indexes, and then look at these two because they're going to be a place where they overlap. You're going to want to find the query that runs, or queries that run constantly over and over again, that are constantly scanning AK pages. These are going to be the big bang for the buck that you just want to get out of the way quickly. Focus on these. So that was drop table students. Next up, we have BFTP19. Let's see what we got here. So BFTP19 has the same exact story, really. So on yours, Parallelism Gone Wild Spring Break Edition, 500 hours worth of uptime, and then like 23 hours worth of Parallelism, 2,000 hours worth of latch waits. So wild and crazy with Parallelism hitting tables that are up in RAM. You want to go ahead and focus on this exact one as well. Next up, so drop table students said 2016 Service Pack 1, 20 cores, 512 gigs of RAM, cost threshold of 50 and max stop of 8. So drop table students, I like your cost threshold and max stop as a good starting point, but then just do the rest of this work in here. So that's good. Or hire attractive people like me to do it for you. That's always an option. So let's see, what else next? DC Poker. So DC Poker sends a link to screencast. Let me go pop open and check that on my own computer first, just because I've had people try to troll me in the past and because he didn't follow instructions. So let's go paste that in over here and get that into the VM. And now we'll switch over and show the VM. So for this was what, DC Poker? DC Poker 1. So DC Poker on yours, God, why can't people follow instructions? DC Poker, follow instructions. Says sorry about screencast. Yep, okay, you're going to be sorry because I'm going to whip your behind here on the webcast. Sure, it would be nice if I didn't have to flub around here and screw around with zooming in on the damn thing because you wouldn't follow instructions. Note to self. All right, so in 9,000 hours worth of uptime, all right, I'll stop kicking your rear end now. In 9,000 hours worth of uptime, you haven't patched. So let's go take a quick look at what that is, because I suck really bad at math. Select 9,000 divided by 24 hours in a day divided by 30 days. You haven't patched in a year. The hell do you do all day? Sit around on Twitch? You just sit around all day on Twitch and watch other people's streams and try and hope your SQL Server magically heals itself? Come on now. So I would assume that with a name like DC Poker, he or she can have some fun with jokes. So now setting that aside, though, so in 9,000 hours worth of uptime, you have only about 2,400 hours worth of wait time on CX Packet. That's not catastrophic at all in the grand scheme of things. And I hate to cast judgments on 12 months worth of uptime, because who knows if you had a problem 9 months ago versus having it right now. So I'm going to set that one aside. You know, I kind of talk repeatedly about setting default sane thresholds for cost threshold and max step. I'm going to kind of set that one aside for now. I'm going to assume that you heard that lecture. The one that's more interesting to me in there is write log in about 700 hours worth of 9,000 hours worth of wait time. That's kind of interesting. Live coding says only degenerates sit around in Twitch watching other people's streams. I resemble that remark. So the write log, your storage isn't bad. Your write logs are averaging about 3 milliseconds, so it's not catastrophic. Overall, when I look at this, the one thing that I complain about is the damn resolution. The one thing that I would focus on is just go patch, and then the application may have changed enough over the course of the last year that I just wouldn't draw any judgment from wait types overall. I would start by patching this thing and going from there. Next up, so GH and Van. So, because GH and Van, I guess I missed yours earlier. Let's go take a look at GH and Van. And after GH and Van, BFTP 19, didn't I already do yours? BFTP 19, I could have swore I did. Oh, you're absolutely welcome. So let's see. BFTP, oh, I did. BFTP, I already did one of yours, and I'm only going to do one. So, oh, you just pasted it multiple times because you didn't think I saw it. Okay, that's totally okay. I love you. You're fine. I don't really love you. You're all okay. So after GH and Van, I'm going to go do JFN, I'm going to do JF. All right, so now GH and Van. So GH and the Candy Van down by Vancouver. So you have, you have something a little different. The one I'm going to focus on in yours, number 2, trace write at 1,000 hours. Where I get nervous is when people are running profiler traces in production. The way that I can tell is that the hour sample, which is your uptime hours, doesn't match the hours of time that traces have been running. One of two things happened. Either someone installed a monitoring tool for a span of time, but not the entire time the server was up. Maybe they tried an evaluation of Quest Spotlight, whatever, and deinstalled it. Maybe they just installed it 1,000 hours ago. Or maybe some yo-yo is running a profiler trace in production. Don't do that. Don't, especially not for 1,000 hours. So a brief word about profiler traces, and I've talked badly about them before, even this morning. A brief word about profiler traces, though, they will slow down SQL Server. They have a huge, massive overhead depending on what you gather. And you'll often hear presenters like me say you should adapt to a more modern method like either SP Blitz Cache, extended events. Both of those are good. I do want to say, though, it is possible to make extended events have just as much overhead as a profiler trace. If you do it wrong, you can bring a server down with extended events. And usually whenever I say, hey, you can bring a server down with extended events, someone pops up in the chat and is like, I brought a server down with extended events. I haven't, but only because I've been scared to death of doing it, so I'm constantly backing off on it. Before you go and do extended events over in production, do one of two things. Either watch the Pluralsight course on an introduction to extended events, which is totally free this month, or try Eric Darling's SP Human events. So SP Human events is available over at ericdarlingdata.com. So at ericdarlingdata.com, he has this thing up here, SP Human events. I'm going to copy paste that out, and I'm going to put it over in the Slack or in the chat. This is a stored procedure that will help you set up an extended events trace and analyze the output way easier than trying to do it yourself with the GUI or trying to write any kind of XML queries. There are two kinds of people in the world. There's one kind of people who do not like to write XML queries. That would be me. And then there's Eric Darling, who actually likes doing XML queries. So there you go. I believe that was GH and Van, BFTP19, so sent the same one again. JF, so JF I'm going to do next. And then after JF, I'm going to do DBA, but not DBA. All right, so paste that in. And while I do this one, actually, this is so similar to ones we've done earlier. So with yours, it's Parallelism Gone Wild Spring Break Edition. Everybody got a Parallelism key in the car and all that. So queries are going wild and crazy with the Parallelism, and they're reading pages that are stored in RAM. This is kind of the good part for you. You're not waiting on reading all these crazy amount of 8K pages from disk. It's not that you couldn't cache it. You cache tons of data. However, we're just repeatedly asking for the same kinds of data, doing table scans over and over again. So for you, for JF, you want to do the same stuff that I've told a couple of other folks here around make sure to set your cost threshold for Parallelism and MaxStop to sane defaults. Get high value missing indexes, but then look for this combo 1-2 punch. Queries that are running all the time and scanning tables. It's probably going to be a eureka moment. You're going to be like, oh my God, I didn't know that was running that often. And that'll be the thing that gets you across the finish line. Next up, I'm going to hit DBA, but not DBA. And after that, I'll hit LG Fritz, who I'm wondering if Lou Fritz, a friend of mine from Chicago. Although I think Lou might have moved. I can't remember. I want to say he was moving. So let's see here. So this is DBA, but not DBA. Yours is a little different. Okay. Yours, the top two are Parallelism. And you've heard me give the Parallelism speech a bunch of times by now. Set your cost threshold for Parallelism and MaxStop as sane defaults, then move on past that. Then underneath that, down here, page IO latch. But you don't see any latching other than this one right here. What this means is that SQL Server is having to go parallel to read a lot of 8K pages, but these pages are not cached in RAM. We're having to read them up from disk in order to put them up into memory. And DBA says, not DBA says set at 8 and 50. Good, that's good. The next thing you're going to be doing is finding queries that are scanning tables or doing lots of I/O work, but you don't have enough RAM. And I say that, it's kind of tricky to ever say that. When you wait for storage, it's about 30 milliseconds, which makes me think you're not on great storage, you're not on like flash storage. So in here, I've given these advice to other people. For you, really, it's going to come down to the two then. Get all database equals one, look for high value missing indexes, and then go look at SP Blitz Cache sorted by reads. But then the next thing that I would also look at is add memory. The reason why I say that is you might be in one of those situations where you're just basically running this thing on my laptop and SQL Server's having to over and over again scan things that aren't up in RAM. If you know, tell me how much memory you have over in chat. Give me a rough idea of how much memory you have and how much data you're supporting with that. Like what's the total data size across all of your databases? Is it 100 gigs, 500 gigs, a terabyte, 10 terabytes? Because I think they might be a little out of whack. It might be that, for example, you've got 16 gigs worth of RAM and you're trying to host a terabyte worth of databases. 64 gigs is a really good start. Now, how much data are we supporting? Is it like a terabyte of data, half a terabyte? Because if it's like 300 gigs or less, then I'm not too worried about that. But the other thing I'd mention too is because you're on a fairly recent version of SQL Server, 2.5 terabytes, there you go. Okay, so you're on a fairly recent version of SQL Server. You're on 2016 or newer because I see the combination of CX Packet and CX Consumer. Even if you're on Standard Edition, you still can support 128 gigs worth of RAM. And that is really just what SQL Server Standard can address. It'll actually use above and beyond 128 gigs, plus you have the OS will use memory and any other services that you have installed. So I know your managers might be like, oh my God, 64 gigs is a whole lot. You even got enterprise. Okay, so let me just do the math on this for a second. How many cores did you say you have? I don't know if you said how many cores you have. Let me go back and look at the chat. I don't see you have how many cores you have. But Enterprise Edition is $7,000 USD per core. I'm going to guess that you've got, let's say, at least 8 cores. So in terms of, it says we're maxed out in what the VM will give us for RAM, 8 cores. Okay, so you're running $56,000 worth of licensing on my laptop. Now I get that whatever bozo is running your VM admin can't give you more RAM than what my laptop has, but that would be the point where I just kind of keep in mind for management that 64 gigs of RAM was a long time ago. That's laptop territory now. And if I tried to run a 2 terabyte database on this laptop, I would be screaming in pain. It's absolutely terrible. To give you perspective, my desktop, the desktop I use for training classes, 128 gigs of RAM. That's just my desktop. Nick Craver, who's on the call, I think their standard desktop developer build is either 128 or 256 gigs of RAM these days. So just keep it in perspective that there's only so far these two can take you when you're trying to host 2 terabytes worth of data on 64 gigs of RAM. You can do it, it just gets harder and harder. You're already seeing how hard it is. All right, Nick says 128 gigs of RAM because they need to make bigger DIMMs. Yeah, it's weird how that all of a sudden the tipping point will hit and then all of a sudden we'll be able to put half a terabyte of RAM in our desktops again. All right, we'll take one more before we blow out of here. So, I said I was going to hit Lou. So LG Fritz. So let's copy Lou Fritz's in and do his. So let's LG. Look at that, all with the fancy pants array here. So Lou has, in about 100 hours worth of uptime, about 800 hours worth of parallelism weights. Now, there's more details on here. It's 32 cores. Okay, I'm glad you said this, Lou, because I'm assuming it's Lou. It could be Louise for all I know, or Lisa, or whatever. So I should actually say, and we reboot monthly. Okay, cool. So 32 cores worth of CPU power, 800 hours worth of CX packet isn't that bad. I got it right. Ooh, it is Lou. So 800 hours worth of CX packet on 32 cores isn't really that bad. So I mentioned that, that's right, Richie knows Lou too as well. And so Lou, in case you didn't know, Joris is Richie. You probably did know that. So you want to set cost threshold for parallelism and max DOP to sane defaults. But beyond that, when I look down below that, nothing's happening on the server. So it's really not bad at all. I think you might have unbalanced parallelism, but that's about it. It's totally not terrible. If you've already set cost threshold, good, he says I already have that. So once you've already set that, it's hard to track down the unbalanced parallelism. What I would do is I would actually start, in your case, with SP Blitz cache sort order equals spills. Now, it looks like you're on an older version of SQL Server. I can't tell the exact version, but it's either 2016 unpatched or earlier. Spills may not be available until you fully patch. If you read that 2014, okay, good. It's available on 2014. You just have to be on current patch levels. And I don't know, it was like 2 years ago. They introduced the spills DMV. So try sort order spills because of the vendor. Cool. That spills isn't necessarily directly tied to unbalanced parallelism, but one of the things that I find is that the kinds of queries where SQL Server makes a bad guess on how much data is going to come back, that's when it also makes bad guesses as to where it should land that data. The other way you can try is with SP Blitz cache sort order equals memory grant and look for high grants but low used. And what I mean by that is where SQL Server's like, oh my God, this query needs, 300 gigs worth of memory, but then it only actually uses like 10 megabytes. That's another sign where SQL Server may have made bad decisions that influenced parallelism as well. All right. So that's, David says, I have a beast of a server, 144 cores. All right, this is going to be the last one that I look at. So David will be the last one that I go look at. If I missed your servers, I'll take a second here to do a quick shout out here. So if I missed your servers, by all means, keep posted on the blog, and I'll do another one of these from time to time as time permits. If I missed yours and you want to bail, thank you very much for coming and hanging out with me. Hopefully y'all learned something as we went through this. I really have a good time showing y'all what different weight stats look like, and it's a good educational opportunity for y'all to see what other people's servers look like when they're really in pain relative to yours. That's always fun for me to go see, get a wider scope of the community. So let's see the last one in here. So the last one in here was Clunky's Educational Webcast. Thank you. David says, it's a beast of a server, 144 cores, 1.3 terabytes worth of RAM, 2016 Enterprise. Okay, let's go look and see. So we have, so just scrolling down, 1 terabyte worth of RAM, yeah, 48 gigs. You just wanted to show off your screenshot, right? What the heck? Oh, no, okay, all right. So you didn't, I thought the way you'd set up the screenshot, I thought it was cost threshold was 0 and max stop was 0. Okay, so you set your cost threshold and max stop appropriately. So up here on the top, you have two different things going on. So one up on the top, you have parallelism gone wild, queries that are repeatedly scanning pages that are stored up in RAM. You're not waiting on storage, obviously. You got lots of stuff cached up in RAM. What you're going to want to go find is queries that are repeatedly running and scanning large amounts of 8K pages. Then the other thing you're going to want to do is those intent exclusive locks. That's kind of nasty. Yeah, Clunky says for a millisecond, all I saw was zeros. And I'm like, no! So the first major thing that I would go and focus on is just to pop back over to this screenshot. And I know that you've already done the top piece there, but you need to do this set in here, SP Blitz Cache sort order equals executions. So that 1-2 punch is going to catch your top 3 weights. The other thing with that intent exclusive lock, that's really interesting that the queries are wanting intent exclusive locks. I think you might have a case of, under indexing. Okay, and so you see how it says over here, average per weight is 3.5 seconds. 3.5 seconds because queries want an intent exclusive lock. What I bet you're running into is deadlocks due to multiple updates or inserts, updates, or deletes on the same table at the same time, where SQL Server doesn't understand how many rows are going to be impacted. He's like, well, maybe there are only going to be a few rows, but maybe they're going to be a spectacular amount. And so queries get started and then they deadlock, which is why we have the relatively short 3.5 second average duration. You are going to be hitting deadlocks, probably deadlocks out the wazoo. In order to troubleshoot those, go watch or go hit SP Blitz Lock and start analyzing and slicing and dicing through there. All right, that is everything we'll talk through today. Hopefully y'all had fun and learned something. Thanks a lot for hanging out with me over the last couple of hours, and I will see y'all around the blogs and over in Slack. Adios, folks.